Hello everyone and welcome back to our third video in the Grade 4 Common Core Standards Succeeding in 4th Grade Math playlist. And today we're going to be discussing numbers and operations and specifically look into fractions for 4th grade. So let's start by extending our understanding of fraction equivalence and ordering. Okay, what does this mean? Let's go to the first part here. You have to understand and know how to explain why a fraction such as a over b is equivalent to a fraction, okay? So if I said, let's multiply the a by a certain number, then multiply that same number to b, okay, how is that going to change the equivalence? Okay, well, actually, it doesn't change the equivalence at all, okay? Let's look at 5 over 8, right? And let's say I'm going to multiply 2 to the top and bottom. Okay, then I get 10 over 16. Okay, 10 over 16 is the same as 5 over 8, except you multiply the top and bottom by 2. If you wanted to simplify 10 over 16, you would get 5 over 8, right? So essentially, 10 over 16 is therefore equivalent to 5 over 8. Okay, and let's go ahead and look at the second part here, okay? We're comparing two fractions with different numerators and different denominators, right? So we look at 4 over 8, right? And we look at 1/2, right? Those two are equivalent to each other, right? Because all you did is multiply the top and bottom by 4. 5 over 8 is greater than 1/2, right? Because if you multiply the top and bottom by 4 for 1/2, you get 4 over 8. And we know that 5 over 8 is bigger than 4 over 8. Now 3 over 8 is less than 1/2 because once again, we can multiply the top and bottom of 1/2 by 4 to give us 4 over 8, and we know that 3 over 8 is less than 4 over 8. Okay, now we want to know how to build fractions from unit fractions. Okay, we have to understand addition and subtraction of fractions as joining and separating parts. Pretty simple. So if I had a pizza, 2/6 of a pizza, right? And I add 1/6 of a pizza to it, I get 3/6 of a pizza. And that's simple addition of fractions. Now, we can also know and understand how to decompose a fraction into a sum of fractions. Okay, so 3/8 can be split into 1/8 plus 1/8 plus 1/8. 3/8 can also be split into 1/8 plus 2/8, right? And lastly, 2 and 1/8, right, can be split into 1 plus 1 plus 1/8. So really, it's just understanding that, hey, if I have a fraction, I can split it into X amount of parts and still end up with the same result. Now, continuing on this understanding, we should also know how to add and subtract mixed numbers with like denominators. So if we look at this example at the bottom left here, we have 2 and 1/6 plus 3 and 1/6. Okay, so first you want to do 2 plus 3, and that gives you 5. Then you want to do 1/6 plus 1/6, right? And 1/6 plus 1/6 is going to give you 2/6. So you have 5 and 2/6. Now 2 over 6 can be simplified, right? You divide the top and bottom by number 2, right? Because 2 is a common factor that goes into both of them. So therefore you get 5 and 1/3. Apply that same logic. I'll let you do this one on your own, right here. 5 and 7/8 plus 8 and 5/8. Now, part 4 is to solve word problems involving addition and subtraction of fractions, referring to the same whole and having like denominators. Okay, so Cy has 4/8 inches of pink ribbon. Emily has 3/8 purple ribbon. How many inches do they have all together? Simple problem, right? You're just going to add 4/8 inches to 3/8 purple ribbon, right? So we get the pink ribbon plus the purple ribbon. So 4/8 plus 3/8 is not 7/16, it's 7/8. Okay, remember, in addition, subtraction, you are always going to keep the same denominator throughout, okay? So 4/8 plus 3/8 will simply be 7/8, okay? So 7/8 inches in all. And as you can see that pie, right, we have 7/8 of the pieces filled out, right? We can say the green represents pink, and we can say the blue represents purple, and that kind of shows the entire pie. Okay, so when you look at fractions, you really just want to think of it as a piece of pie. It's a really, really good way to think. Okay, and I'll let you go ahead and solve this problem on your own, okay? And I'll leave the answer to this one in the comments below, so you can check that after. Okay, so let's understand how to build fractions from unit fractions. So part 5 says understand a fraction a over b as a multiple of 1 over b. So 5 over 4 is the product of 5 times 1 over 4. Okay, so if we're trying to say, okay, understand 5/4, right? All you have to understand is, okay, I'm getting the number 5, the whole number, and multiplying it by the fraction 1 over 4. Okay, so that's the understanding of that. Now look at part 6 here. This is a pretty simple problem. Read it to yourself, right? It says understand a multiple of a over b as a multiple of 1 over b, and use this understanding to multiply a fraction. Okay, so let's look here. We're looking at 6/5, right? There is more than one way to represent this. First of all, we can go ahead and represent this by saying, okay, I'm getting 3 times 2 over 5, right? Because 3 times 2 on the top gives you 6, and the bottom stays 5. Then you can also recognize it as 6 times 1 over 5. 6 times 1 equals 6 at the top and 5 at the bottom, so 6/5. So if you know how to understand a multiple of a fraction and then relate that back to a multiple of 1 over that fraction, you're going to have a much better and easier understanding of fractions in general, okay? Cool. Finally, let's look at the 7th part, right? We might have one more slide, but let's look at the 7th part. Solve word problems involving multiplication of a fraction by a whole number, okay? So this is kind of what we were working on earlier, but let's look here at this example, okay? It's just a word problem now. So, for example, if each person at a party will eat 3/8 of a pound of roast beef, okay, and there will be 5 people at the party, how many pounds of roast beef will be needed? Between what two whole numbers does your answer lie? Well, if each person is eating 3/8 pounds of roast beef and everyone is eating roast beef at the party, and there's 5 people, we simply do 3/8 times 5, okay? And that's simply going to be 3 times 5 over 8, so 15 over 8 pounds of roast beef, okay? And 15 over 8, if you think about it, lies between 1 and 2, right? Because 8 over 8 is 1, and 16 over 8 is 2, okay? Cool. Let's finally look at this last one over here. Okay, we want to understand decimal notation for fractions and compare decimal fractions. Okay, so let's look at the first part. It says express a fraction with denominator 10 as an equivalent fraction with denominator 100. Pretty simple, okay? Give me 1 second. So, yeah, it's pretty simple. Let's look at 3/10, right? 3/10 is the same as 30 over 100, right? So if you look at 3/10, right, it's going to represent 30 over 100 in the same way as 30 over 100 would be represented, right? Now 4 over 100 is added to 3/10, and you say, okay, since 3/10 is 30 over 100, it's simply going to be 34 over 100 for the answer, okay? Let's look at the second part here. You want to use decimal notation for fractions with denominators 10 or 100. Okay, pretty simple. If we want to rewrite 0.62, we're going to rewrite that as 62 over 100, right? Because that's simply how you're going to rewrite a decimal point, right? Since it's from a one whole, right, it's going to be 0.62, and you're going to write that as 62 over 100, right? Now, you can then describe that length as 0.62 meters, right? So just understand that 0.62 can also be used to represent certain lengths, right? Now, the third and final part is compare two decimal to hundredths by reasoning about their size, right? So if we're looking at 0.55, we know that's less than 0.60 because we know 55 is less than 60. If you look at 0.97 and 0.74, we know 0.97 is greater than 0.74 because 97 is bigger than 74. And if we look at 0.5 and 0.50, we know that those are equal to each other because because 50 is equal to 50, okay? Okay, cool. So that's pretty much it for today, okay? I'm going to go ahead and stop the share there. I hope you guys enjoyed the video. I'm kind of outside today for a change, but that's pretty much it. So I hope you guys enjoyed, and I'll see you guys next time.